So today in this class, let us solve some numericals. Let's read the first one and solve this one. Using parallel axis theorem, obtain the expression for moment of inertia of rectangle B into D about the axis passing through its base. So the geometrical section that is given in the question is the rectangle. It is a rectangle. And the size is given as B into D, right? And now let us say that the x-axis for the section will be passing from here and y-axis from here. This is my y, this is my x. And now the height, the distance from this point till the base will be d by 2, and the distance from this point till here will be b by 2, right? Let us name this rectangle as A, B, C and D, right? Now we are asked to find moment of inertia, about the axis passing through its base. So for this rectangle, the base will be AB, right? The base here will be AB, and this base AB is passing parallel to the centroidal axis XX axis here, right? So this one here is my centroid G. Now by parallel axis theorem, the moment of inertia about IAB will be equal to moment of inertia of this rectangular section passing through XX axis. So moment of inertia about XX axis plus area of this rectangular section into the distance between these two axis, that is AB and XX axis. So that distance will be this distance h, which is equal to d by 2 here. So it will be into area into the perpendicular distance square. So this is the statement of parallel axis theorem. Now let us find moment of inertia about IXX. How much will it be? For rectangular section, it will be BD cube by 12 plus what will be the area of this rectangle? It will be B into D, right? What is the height between these two? The difference of height between these two axes, it is D by 2 and its whole square. Now let us further simplify this one. It will be BD cube by 12 plus, here it will be, if I multiply this with this, I get B into D square. So that will be D cube divided by 2 square will be 4. Now if I find the LCM of 12 and 4, what do I get? 2, 6, 12, 2, 2, 4, 2, 3, 6, 2, 1 is 2, right? So my lowest common multiplication for this 12 and 4 will be equal to 2 into 2 into 3. How much will this be? 2 to 4, 4, 3, 12, right? So here I can write it as our LCM, we got 12. So now to do the addition, we have found the LCM. Now how much times in the denominator here will make it 12? It is times 1, right? Similarly for here it is times 3. So the same number you have to multiply it in the numerator, times 1 times 3, right? So how much will I get from here? It will be BD cube plus, how much will it be here? It will be 3BD cube, right? So from overall, what do we get? Since these are the same, it has their variables are the same, it is like terms, so I can add them up and it will be 4BD cube by 12. If I further simplify this, it will be 3 and I get BD cube by 3. So my moment of inertia about the base IAB is equal to BD cube by 3. So this is my answer. Now let us solve the second question. It states, determine moment of inertia of a rectangular section 100 mm wide into 200 mm deep about an axis passing through the centroid and parallel to 100 mm side. Also determine radius of gyration about the same axis and moment of inertia about its base. So again, the geometrical section that is given to us is again a rectangular section. So let us draw the section first. Rectangular section, let us name this rectangular section as A, B, C and D, right? And let's stated that its base is equal to 100 mm. My base here B is equals to 100 mm and my depth is given equal to 200 mm, right? And the axis, the two axes, x-axis and y-axis for the section will be passing in this manner. Y, and this is the centroid G. Now what will be the distance from A till this point? So it will be equal to depth by 2 and my depth here is 200 divided by 2, right? So what will be my the measurement from this point till B? It will be equal to base, it will be half of the base, which will be equal to 100 divided by 2, right? Now let us solve. What are we asked to find? Number 1, determine moment of inertia of a rectangular section passing through the centroid and parallel to 100 mm side, right? So moment of inertia passing through the centroid, this centroid here, and parallel to 100 mm side. Now we know which axis. The axis which is running parallel to 100 mm side here is x axis here, right? If it said find moment of inertia passing through centroid passing through this centroid and parallel to 200 mm side, then we would be finding moment of inertia about y plane. But right now we are asked to find parallel to 100 mm side, so it is the x axis. So if I find moment of inertia about I x, it will be equal to b d cube by 12, right? So how much is my b here? My b here is 100. How much is the depth? The depth is 200 cube divided by 12. And now let's see how much it will be equal to. Let's calculate. So now it will be equal to 100 into 200 cube divided by 12, right? So this will be equal to, it is coming this much. So if I do this, it is equal to 66.67 into 10 raised to power 6, right? 67 into 10 raised to power, it was 10 raised to power 6, yeah, 10 raised to power 6 m raised to power 4 is the unit of moment of inertia. So the first one is over. Now in second, they have asked us to find, also determine radius of gyration about the same axis. So the same axis here is IXX, right? So we have to find radius of gyration about the same axis. So how much will it be? Formula for radius of gyration is kxx, it is about the same axis, equals to root over of IXX divided by its area, right? So how much is my IXX? IXX is equals to 66.67 into 10 raised to power 6 divided by, what will be the area of this rectangular section? It will be 100 into 200. Now let us see how much this will be coming. Let's calculate again. Right, root over and my answer from the previous, which is the same answer I have, divided by its area, 100 into 200. So it is coming 57.73. 57.73. Now what will be its unit? It will be in mm, radius of gyration. For radius of gyration, the unit will be in mm. Now the third one, they have asked us to find moment of inertia about its base. So moment of inertia about its base will be equal to, now we have to find moment of inertia about its base, right? So the base here is AB, is the base for this rectangular section. Now this AB is again running parallel to this x-axis here. So if I find moment of inertia about IAB, I have to use parallel axis theorem to find moment of inertia about IAB. So the parallel axis theorem for this will be IXX plus AH square, right? So how much is my IXX here? it is 66.67 into 10 raised to power 6 plus area is 100 into 200 and my height here is 100. 200 divided by 2 is 100 square, right? So if I again solve this in a calculator, I'll be getting 66.67 into 10 raised to power 6 plus, let's open the bracket, 100 into 200 into 100 square. Square. So how much are we getting? We're getting 266.67 into 10 raised to power 6, right? So we're getting 266.67 into 10 raised to power 6 mm raised to power 4. So this is my answer. I hope it is clear again, this numerical also. Now let's solve the third numerical. Find the polar moment of inertia and radius of gyration for a hollow rectangular section, external size 200 mm into 300 mm, internal size 150 into 250 mm. So this time the geometrical section given is a hollow rectangular section. So its size are given as 200 for the external rectangle into 300. Okay, so from here to here it is 200 mm and from here to here it is 300 mm external, right? Now for internal the size is given 150 into 250. So 150 into 250. mm here, and from here to here, from here to here it is 250 mm, right? From here to here it is 150. Okay, so let us name this rectangle as A, B, C, D. Then internal E, F, G, H. Okay. Now let us draw the axis. X axis passing through this plane here, and Y axis passing from this plane here. Okay, so this one here is my centroid G. This is x axis, and this is my y axis, right? Now, what will be this height for the external rectangle? It will be capital D divided by 2. So my depth here is 300. So it will be 300 divided by 2, which is equals to 150 mm, right? So what will be this measurement here? It will be equal to, for the external it will be equal to 200 divided by 2, which will be equal to 100 mm, right? Similarly, let's find for the internal rectangle also. For the internal, this height here will be equal to small d divided by 2. So the small d here is 250. So 250 divided by 2, how much will it be? It will be 175 mm, right? And again, what will be this measurement here? It will be equal to 150 divided by 2, it will be equal to 75 mm, right? So we get all the measurements. Now let us find polar moment of inertia. The first they're asking us to find polar moment of inertia, right? Polar moment of inertia is also denoted by IP, right? So how do you find IP, polar moment of inertia? To find IP, we need to find moment of inertia about Ixx and moment of inertia about Iyy. We need to find about Ixx and Iyy and add these two, and then we'll get moment of inertia for the third plane, which is IP. So it will be equal to Ixx plus Iyy, right? So Ixx for this hollow rectangular section will be equal to 1 by 12 BD cube minus BD cube, right? This is my Ixx plus Iyy will be equal to 1 by 12 dB cube minus small letter dB cube. So this will be my Ixx and Iyy. Now let us further solve it. 1 by 12. How much is my B? B is 200 into D is 300 cube minus small b for the inner rectangle is 150 into D is 250 cube, right? Plus 1 by 12 D for the external rectangle is 300 into B is 200 cube minus D is 250 into 150 cube. Now let us solve this and get the value in from the calculator. Okay, so let us solve here directly. 1 by 12. Let us open the bracket. Two brackets will open. The first one is 200 into 300 cube minus 150 into 250 cube. Bracket close. So for this I'm getting 254. So my Ixx is coming 254.68. So it's coming 687. So let us round it off and make it into 254.69 into 10 raised to power 6. 254.69 into 10 raised to power 6. So this is my Ixx. Let us find Iyy also. So Iyy will be equal to 1 by 12. Let's open the bracket. 300 into 200 cube minus 250 into 150 cube. Right. So my Iyy is coming equal to 129.69 again into 10 raised to power 6. So it's coming 129.69 into 10 raised to power 6. Now if I add both these up, I'll be getting plus 254.69 into, let us put a bracket here, into 10 raised to power 6 and bracket close. So I'm getting 384.377 it is coming. So let's make it 384.38. 384.38. So it's coming 384.38 into 10 raised to power 6 mm raised to power 4. Right? So this is my polar moment of inertia IP, which is also a moment of inertia about the third plane, is coming equal to 384.38 into 10 raised to power 6. Now what they ask next? And radius of gyration of a hollow rectangular section. Now we have to find radius of gyration also. So number 2, radius of gyration of the hollow rectangular section, right? So if I find radius of gyration about kxx, my formula will become Ixx divided by area, right? Similarly, if I find it for kyy, it will be Ixx by area. Now I have already found Ixx and Iyy, so all I need to find is the area of this hollow rectangular section. So the area of this hollow rectangular section will be equal to area of outer rectangle minus area of the inner rectangle, right? So how much was B? B was 200 into D was 300 for external rectangle minus B here was 150 into D was 250, right? So this is area. Let us do the calculation again. $200 into 300 minus 150 into 250. So my area is coming 22.5 into 10 raised to power 3. 22.5 into 10 raised to power 3 mm raised to power square. So this is my area. Now let us find radius of gyration about x-axis. So it will be equal to, how much was my radius of gyration about Ixx? About Ixx, it was equal to 254.69. So I have 254.69 into 10 raised to power 6 divided by the area is 22.5 into 10 raised to power 3. So this will be coming equal to root over and 254.69 into 10 raised to power 6 divided by 22.5 into 10 raised to power 3. So you're getting 106.39. So let's make it 106.4. 106.4 mm. Right? Similarly, let's find for KYY. So for KYY, it will be root over of IYY divided by area. So how much is my IYY? From above, we got IYY as 129.69. 129.69 into 10 raised to power 6 divided by 22.5 into 10 raised to power 3. So how much will this be coming? This will be coming equal to 129.69 into 10 raised to power 6. Everything is same. This will be coming equal to 75.92. So it is coming 75.92 mm. So this is my radius of gyration about YY axis. So this is the end of the question for third numerical. I hope it's clear. Let's solve the last numerical for today. A hollow square has inner dimension a into a and outer dimension 2a into a. Find the moment of inertia about the outer side. So this time it's a hollow and it's a square. So let us draw the square, hollow square. Let us name this as A, B, C, and D, E, F, G, and H. Now, the size of this outer square is 2a and its depth is equal to 2a, right? For the inner square, it is a and the depth is a, right? So the axis will be running through the centroid. Let this be x-axis. Now the axis from this plane y. And this is my centroid here, right? Now we are asked to find moment of inertia about the outer side. So moment of inertia about the outer side, right? So it will be equal to, we can take any plane now. We can take AB. If we take AB, this plane will be running parallel with x-axis, right? If I take DC, again this DC plane will also be running parallel with x-axis. If I take BC, this BC plane will be running parallel with y-axis. And if I take AD, it will be running parallel with y-axis. So we have done lots of numerical with axis running parallel with x axis. So this time let us do axis running parallel with y axis. So let us take AD plane running parallel with y axis, right? So let us take outer side AD. So I have to use parallel axis theorem here. So the parallel axis theorem formula will be equal to I y y. Why I y y? Because AD is running parallel with y axis, right? Plus area of the hollow square into the perpendicular distance between the two axes. So what is the perpendicular distance between the two axes? It will be from this to this. This will be the distance. So what will be this distance? It will be equal to 2a divided by 2, which will be equal to a, right? So let us find one by one. First, let us find moment of inertia about y axis, right? So if I find moment of inertia about I y, it will be equal to, for a hollow square section, it will be 1 by 12 db cube minus small db cube, right? So how much is my d for this section? D here for the outer section is 2a. Since it's a square, b and d will both be same, so it is 2a into b is 2a cube minus d will be equal to a and b will be equal to a cube for the inner square. Now if we solve this, what will we get? We'll be getting 1 by 12 and this is whole cube, okay, whole cube. So 2 cube will be 8, 8 into 2 will be 16. So I get 16, and a cube into a will be a raised to power 4 minus a cube into a will be a raised to power 4, right? So with further simplification, I get 16 a raised to power 4 minus a raised to power 4 will be coming 15 a raised to power 4. So this will be equal to 15 a raised to power 4 by 12. So this is my I y, right? So I'm getting I y equals to this much. Now let us find its area. Its area A will be equal to BD minus small bd, right? So how much is my BD? B is equals to 2a into D is equals to 2a minus a into a, right? So what will I get? 2 into 2, 4. So I'll be getting 4a square minus a square. So this will be equal to 3a square. So my area is equals to 3a square and my height is equal to a, right? So now let's find the moment of inertia about I a d, which is equals to I y plus a h square, right? So how much did we get I y? I y came equal to 15 a square divided by 12, right? We got 15a square divided by 12. No, it is 15 a raised to power 4, not square. A raised to power 4 divided by 12 plus the area came out 3a square into the height was a square. So from here what will we get? It will be equal to 15 a raised to power 4 divided by 12 plus 3 a square into a square will be equal to 3a raised to power 4. Now if I find the LCM of these two numbers here, two numbers, so LCM will be equal to, lowest common factor will be equal to 12, right? So multiply by 1 here, multiply by 1, its denominator is not there, so it will be 1 here, so multiply by 12, multiply by 12. So here it will be 4a raised to power 4 plus here it will be 12 into 3 will be 36 a raised to power 4. So this will be coming equal to 15 plus 36 will be equal to 51 a raised to power 4 divided by 12. Now we can multiply this number with 3. How do we know? 5 plus 1 6, 2 plus 1 3. So both can be multiplied with 3. So let's do 3 1's 3, 2 3 7 the 21, right? 3 4 the 12. So I'm getting 17 a raised to power 4 by 4. So this is my moment of inertia about IAD. I hope it is clear. This is it for today's class. See you in the next video.